Okay, so what we're going to do is go over each problem on the study guide like we've done in the past. What I also told you already is that the study guide is like an example of your quiz. Okay, so these are the types of problems that will be on your quiz. Number 5 is going to be a bonus on your quiz. We talked about this, but it's when you do the process on the calculator, it's the R value. But that's the only way you can do the process, so that's why I'm going to make it bonus. But the rest of these are all going to be examples of what you see on the quiz. Okay, so the first one, making a scatter plot. Okay, how do I make a scatter plot? When it says make a scatter plot, what are we going to do? Matt?
We make a graph.
Okay, so we're going to graph. Usually scatter plots are one quadrant. Sometimes they're not, but most of the time they are. Our two categories are height and weight. Since the weight is going to depend on someone's height usually, that's how I know that the height is the x and the weight is the y. And then we have our table of values. So we're just going to graph them as ordered pairs. Now, with scatter plots, we have to figure out the scale. So what do you think would be an appropriate scale, let's say, for our y values, if they go from 62 to 73? Jordan? Is that a hand? No. Okay. What would be our appropriate scale then? Should we do a break?
Yeah.
Okay. Maybe we should do a break. Okay. And the break will be right here. Because your graph always starts at 0. I'm actually thinking also that we want to do a break for our x values. So that we have an appropriate scale. So for our x values, we go from 62 to 73. If we do a break, what do you think we should start with? Josh?
60.
60 is probably good. Okay, and then what do you think? What do you think we should go by after that? Rocky? Choose? Yeah, that's probably good. Okay, 62, 64, 66. Okay, so we go up to about 74. All right, what about for the weight or the y values? What do you think we should start at? 100, yeah, okay. So let's say we start here with 100, and then what could we go up by? 10? Go up by 10. Okay, so there's our scale, and that's probably the hardest part about doing the scatter plot, besides figuring out which one is x and which one is y. They don't tell you. So we're just going to plot the points, and we have our table ready to help us to do number 3 and number 4, but we're going to use the scatter or the table to do our scatter plot, and they don't have to be the exact same. They just have to be as close as possible. So 62, 115 is going to be about here. 63. So we're just going to plot the points. You want to be as accurate as you can, but cluster there because you have several values of x that are the same. Never heard the class so quiet in my life. Maybe I should just videotape all the time. 73. Which one did I forget? 68, 152. Yeah, 68. That one? Right? Okay. So now you can see our scatter plot. We have to determine whether the graph shows a positive, negative, or no correlation to figure out whether we can write an equation for number 3. So is this a positive, negative, or no correlation? Abby? Positive, okay? So if it's positive or negative, usually you're able to describe the meaning. So if we were to describe the meaning here, what does this mean? Based on like what we were doing for the Kahoot, Matt?
The taller you are, the more you weigh.
Okay, usually that's the case. The taller you are, the more you weigh. Okay, so that would be number 2, where you figure out what type of correlation and then describe its meaning if it's positive or negative. Now, also if it's positive or negative, you can write an equation. And you can do this step on the calculator. You can actually do number 1 on the calculator too, where you make a scatter plot, or you can do it like we did here, and you can also write your equation manually without the calculator. So we're going to do that without the calculator here, just in case someone doesn't have access or doesn't remember how. So writing an equation of the best fit line. What do we need to write an equation? Right. Slope, okay, that's a key part. So if we're going to try and find slope, we first need to do a line of fit. So we're going to draw a line as straight as possible through as many points as possible, following our trend. Okay, so I'm just kind of eyeballing it here, but okay, let's say we do our line like that. So going through about 5 points, okay? Someone else's line may look a little different, but as long as you're going through at least 2 points, that's okay. So once we found our line, we need to find our slope, so we need 2 points. The 2 points need to be consecutive, so they need to be next to each other. So let's say maybe like these 2 points, okay? And then we need to look at our table to figure out exactly what those were. So we have one, it looks like at 67, 140, so that's one of our points. And then we have one at 68, 144, it looks like. So this is how we're doing number 3. We drew a line, we pick 2 points from our line, we find our slope. Okay? So we subtract our y's over our x's, and we get 144 minus 140, which is 4, over 68 minus 67, which is 1. So 4 over 1, or just 4. So our slope is 4, okay? From there, how do we continue writing an equation when we have the slope now? Matt?
You take one of the 2 points you put and you put in slope intercept form using x and y to find the
Okay, so let's say we picked the first point. We put in our slope, y equals 4x plus b, into slope intercept form. We pick either point that we chose to find our slope, so 67, 140, let's use that one. And we plug in y for y and x for x. And we're going to solve for b, okay? So we get 4 times 67, 268. And we get 140 equals 268 plus b. And then we have to subtract the 268. So we get 140 minus 268 equals b. So 140 minus 268 is going to give me 112, negative 112. That's not right, so now we need to put it all together. We have our b, we have our m, and we write an equation. So our equation would be y equals 4x minus 128. Now, what I will tell you is if you had something slightly different than that, okay, as long as it wasn't like 1,000x minus 20 or something, then it's probably right. You just may have chose 2 different points on your line, okay? So someone else could have a different answer and still get it right. As long as you follow this process, you will get it right, okay? So that's what you do when you're writing an equation, because that's why it's called the best fit line. It's going to be whatever best fit line you create, okay? Now, if I were to use the line of fit to predict for number 4, okay, this is also something you can do on your calculator, but again, we can do this manually. So if we got our equation, that's all we need, and we're going to use the equation to predict. So if it says use the line of fit, it really means use the line of fit's equation to predict the normal weight for a man who is 84 inches tall, which I looked up is actually 7 feet tall. So someone that's 84 inches tall, we're going to plug in 84 in what value? Because we need to figure out which one's y and which one's x.
X.
The x value, because that's going to be our height. So we're going to plug in 84 for x. So we have y equals 4 times 84 minus 128. So we get 336 minus 128. Which is, okay, what? 200 what? 8. So we get y equals 208. So that means an 84-inch tall person or man, or 7 feet tall, is probably going to weigh around 208 pounds, okay? So that's what that means. But that's how you would use your line to predict, okay? So I just showed you all of these can be done without the calculator. So if you don't have the calculator, that's okay. Number 5, however, cannot. So number 5 is if you did all this in your calculator and you got your equation, it's when you get to the screen with the a, the b, the r, and the r squared, it would be the r value for number 5. That's the correlation coefficient. Okay, number 6, I think we can just kind of go over quickly. Okay, if you're finding the inverse of a relation, what do you do? Matt?
Switch between coordinates.
You just switch the x and y coordinates. So we're going to switch -5 to 13 and then 13 to -5 and just keep going. So we're going to switch all those x and y coordinates and rewrite them. That's all we do for 6. Now 7, you're going to use the 4-step process. Okay, so 7, if you're finding, can I take this off the screen? Okay. If you're finding